Today, it's my turn to show you some presentation and to share with you some knowledge about web development in Python. And today's lecture is actually about FastAPI, as Vlad already mentioned. So during previous lectures and practical assignments, you learned how to create your own web framework. So it actually gives you a huge base, a huge knowledge base to have this deeper understanding of how these frameworks can actually work under the hood. So yeah, and now we will start to learn like real rising star of Python web development, which is called FastAPI. So let's actually start. So what possible advantages can have a framework that is called FastAPI? Well, obviously, it's something fast, right? It's something that should be fast. And it's true, because FastAPI is really fast, and it can really compete in terms of performance with such real high-performant technologies as Node.js and Go. And also, it's really fast to code because, it's really easy to write code in FastAPI and to deliver it to production. Also, FastAPI is really lightweight compared to Django and Django REST framework, for example, because those frameworks has a lot of different libraries, and in the most of the projects, you just don't need them. You just don't need all these technologies. Sometimes you just need something more simple, something more fast, something more lightweight, and FastAPI is just perfect for that. And also, FastAPI is much more easy to learn because in Django, for example, there are a lot of things that are processing automatically, and sometimes it's not very obvious why it works in such way. And FastAPI in this case is much more obvious and much more easy to learn. Also, FastAPI is asynchronous. We will not talk a lot about asynchronous programming in this lecture, but it actually really boosts performance of this framework because it allows this framework to complete and handle several requests in the same time. So you don't have to wait for one request to finish to start another request, and it's really boosts performance. Also, FastAPI have powerful validation using Pydantic. We will talk about it a little bit later. And really cool thing is auto-generated documentation. It's very important, very useful. We also will talk about it a little bit later. So, interesting fact about FastAPI, not about just FastAPI, but about all these technology stack, about Python, which is you currently familiar with, about FastAPI that we will discuss and learn today, and about LangChain, which is kind of, for now, is unknown technology, but it's a little spoiler. You will know what is it. So because we will.
Are you sharing
your screen in Zoom? Maybe I'm not. That's okay. I just need to find my Zoom. I'm sorry. How can I post it? The whole screen? Share. Okay. Okay, I'm sorry, guys. Can you see it now? But now I should somehow.
this thread?
Okay. Cool. So yeah, we can continue now. But actually, this stack is used in creation of Dia AI. Have you heard about Dia AI? It's a It's a helpful assistant that will help you about some like government questions. It works in the web platform, so you can, for example, like ask some question about some government services, some administrative services, and it will help you. It will answer you. So yeah, it's another proof that this technology stack is relevant, and soon, and FastAPI is soon to be an industrial standard. So let's actually speak about documentation. As I mentioned previously, it's a very important and a very cool detail in FastAPI. So when you write some code in your FastAPI application, it will automatically generate documentation for you, and actually not just in one example, but in several, in Swagger documentation and in Redoc documentation. But why documentation is important in the first place is because actually it can save a lot of time for developers, and it will prevent some miscommunication, it will prevent some confusion, because everything is actually documented in one place, and for another developers, it's absolutely clear how to use your API, how to use your backend. So yeah, there just won't be a lot of mistakes and miscommunication between developers. And it saves a lot of time because, for example, you have your backend, you have a team of backend developers, several people, but you have your front-end developers, also several people here. You have also mobile developers, and if they start asking every time a lot of questions, it will take a lot of time. So documentation is actually really, really important, and it's a huge feature in your FastAPI framework application. So yeah, let's continue. Let's play a small game. So here you have 4 code snippets. On some of them, on most of them, it's your code from your custom frameworks, but in one of them is code in FastAPI. How do you think? Where is FastAPI hiding? Yeah, it's not very obvious, to be honest. Your frameworks are pretty similar. Any ideas? Maybe just guess. C. Do you have any other thoughts? No, just guess, maybe, at this point. Okay, actually, right answer is C, obviously. Why do you think that it's C? What? Okay, in the brackets. We actually will talk about it later as well, why we have brackets here. But yeah, thank you a lot, guys, for your code snippets. Was it that different from what you created in your frameworks? Yeah, it's pretty similar. So, and I think now we will have more understanding why we have such notation, why we have these decorators, how they may work under the hood. It's not specifically how they will work in FastAPI, but maybe it's something similar. But yeah, so let's take a look on FastAPI Hello World. It's really easy. Actually, all you need is import it and create your application and register your roots just like you registered your roots in your custom framework. And actually, it's just how you create your app in your custom framework. So, in order to do that, you just need to run some commands in your terminal to install some packages and some dependencies. So let's actually do that. Let's actually jump to Visual Studio Code and do some coding. So first things first, I already have this project, but I still need to install some dependencies. But I will create some main.py file and start uploading dependencies. First things first is we need to create our virtual environment here. So let's create it. Python. Zoom in.
The command plus.
Command plus. Wow. Python m.venv. And it will create virtual environment for us. Then we just need to activate this environment. Source.venv bin activate. Yeah, so we activated our virtual environment, and then we need to install some dependencies. You can use it with pip. You can do this with pip install FastAPI standard. It will install FastAPI and install both FastAPI and some additional dependencies of FastAPI, such as Pydantic and so on. Also, you need to install UVicorn. UVicorn is something similar to GUnicorn, but the difference is it can work asynchronously and to handle different requests at the same time, as I mentioned that earlier. UVicorn.
And it will work for.
Yeah, it will work. Yeah. So we actually have everything we need, so we can just create our application. So let's import from FastAPI, import FastAPI, and let's actually create our application. Wow, that's all we need. Then we just need to launch our server. And how we can do it using UVicorn is just UVicorn. Then we should write name of file where we have our application. It's main, then semicolon, and then name of our object that have our FastAPI application. So it's app. And also we can tell our server that every time we do some changes in our code, we should actually restart our UVicorn server, and our changes will be visible like almost instantly. So for that, we should add reload. Let's run it. And yes, we have our server running. Let's just take a look. Yeah, it's not found, but that's great. Should I also command plus? Yeah. Let's take a look actually at documentation. It's pretty empty here for now, but we'll have more routes later. Oh, okay. So let's actually create some simple get routes. To do that, we should actually also use a decorator. We should use a get decorator. Let's specify some paths. Let it be like some test home. Okay. And here we also need to create our function. Let's call it also test home. And let's also explicitly specify that we want to return a string. And actually, let's return the string. Let's save it. Do you have some issues with installing, or why? What issues?
And the control the information problems once we get again.
I will show it, I think, later. You can do it during your class assignment. I think for now we can just move on, right? Okay, so it's a simple get root of our FastAPI. And if we refresh our documentation, you'll see that it's already generated. It's already generated in your documentation. And you can actually take a look here. You can see that FastAPI by default will return 200 status. And it already knew that the return type will be string. And it will be actually very obvious for front-end developers that it will be a string. So they will expect a string from this request. And it's cool. Let's actually add some more parameters here. Let's actually add, and just forget, summary, I think, yeah. Summary, test, let's call it test route. And let's add some description. This is test route. And now, when we save it, and when we again reload our documentation, you'll see that you have this summary here, and you have this documentation here. And it's actually the way how you can describe all your routes and explain why your front-end developers need to use this route, how they can use this route, and so on. So yeah, that's also very helpful. Okay, so now let's also create something that is more difficult. Let's create another route. Get. I think we can actually create some collection of homes. And here, let's store some, it will be a dictionary. It will be a list of dictionaries. So we need to wrap it in a list. Oh. And for example, our homes will have like ID, which is ID, and some, for example, city. Yeah, it can be an integer, and city is a string, for example, Kyiv. And then let's actually add those parameters for our request. So for example, here in our pass, we can also, just like in your custom frameworks, pass some arguments. So you can pass it here, and you can receive that in your route handler, just like in your custom frameworks. So when we save it and when we restart our documentation, you will see some changes. First things first, you will see that you have this ID integer here, so it's also a cool thing. But also in your expected responses, you'll see 422 validation error. That's because your framework will expect this ID to be an integer, and if you will pass something that is not integer, it will automatically raise an error with 422 status. So let's actually use that. Also, the interesting thing about Swagger documentation, the documentation that you see now, is that you can make requests directly from this documentation. So here you can, but let's just finish our code. Let's just add this ID here and save it. And now let's take a look. So you can just make requests from your documentation, and if you send request here, that's probably because I forgot to add formatting for this string. Okay, so let's again refresh it. Let's try it. Let's pass some integer, and you'll see, yeah, so it's added for your string and it's returned. It works. Cool. Hooray. But if you try to paste something different, it won't allow you. Swagger won't allow you, but let's do it. I think, okay. I just somehow copy that. Let's just write some nonsense.
2 slashes, right?
You'll see this long string that is saying about input should be a valid integer. And it's obviously not a valid integer. If you take a look in your console or in your network, you'll see that it has 422 status error. So yeah, that works. Wow. So that's actually how you pass your pass parameters in your request. But also, let's add another parameter. We can add this city, for example. City that is a string. But not actually just string or none. That's actually another way how you can write these optional parameters. You can write it just like string or none. So it can accept string or none. And let's make it none by default. And let's also add it here. City and city. So we will not add it into our pass, but we still add it here. And let's save and again reload our documentation here. And what will you see is that you have the city parameter here, but it's not a pass parameter, it's actually a query parameter. So where you add some parameters for your function here, but not specify them in your pass, it will FastAPI will automatically handle that as a query parameter. So it's, I think, very easy and very obvious approach. So yeah, let's again try it. Let's write some ID. Let's write some city. Let's let it be Lviv in this time. Yeah, it works. Cool. Okay. So let's actually get back to our presentation and let's continue. So we already knew that FastAPI is something that is fast, right? But also FastAPI is something that is about API. And what is API? Do you know what is API? Yeah.
On the server, so both. So connect, so okay.
Yeah. That's actually something that is between backend and user. It's a set of rules how users can use your backend. And it's actually secures your backend and gives some guidance for user that will use your backend. So, and when we talk about API, in most cases, we talk about RESTful APIs. What are RESTful APIs is actually also a very interesting topic, but now all we need to know is that RESTful APIs are really good and they are really good at working with HTTP protocol. And you should already know about HTTP protocol. You used GET requests a lot. You probably heard and used about POST requests, but there are not just GET and POST requests. There are a little bit more requests. And here you can see this very ChatGPT-ish example of restaurant, where, as you can see, you may have GET request. It's like request when you asking for your menu. You can have POST request. It's when you're making an order. When you're creating something, you send a POST request. You also have PUT request. It's when you want to completely change something. So you already have an order, and then you're like saying, wait, I just need to completely change everything. Change all meals, all dishes, and so on. And also you have a batch request. It's when you want to slightly modify something. To, for example, I don't want a Coca-Cola, I want an apple juice, something like that. And you can cancel, for example, your order using delete requests. It's obviously for deleting something. Yeah, so they can be used just as you use get and post. So it's pretty the same. And actually nothing can really stop you from, for example, deleting your objects in post request, or for example, like modifying your objects in get request. But it's not a very good practice. You should really follow those semantic meanings of those methods. So yeah, let's continue. And if you, for example, talk about post request and get request, you also knew that there are some differences between them. Because get request is something lightweight, something fast. You ask about something, you don't need to send something for your server. You just ask about something. But post is different. You need to create something. And in order to create something, you need to provide some information for your server so it will be able to create something. So post request, as well as put request, as well as patch and delete has this body, has this payload inside of a request. So, and get doesn't have that. So, yeah, another thing about RESTful APIs is that these data transfers, data inside of this request should be structured. And the most popular way to structure data inside request is JSON. Have you heard about JSON? Okay, so JSON is a structured data format that is very popular. I think it's the most popular in modern systems, and it allows us to share information that is actually quite obvious. And in most cases, JSON is a object. I'm kind of bad on an object. Object that has some keys, which is a string, and some values that can be like really different. For example, like 1. But also JSON can be a string, or not a string, but a list. And also it can be a string, and also can be an integer, and also can be a float. Okay. And also it can be a boolean, so it's true. And also it can be a null. And in most of the times, JSON is just a combination of these standard types. So it can be a list of strings, it can be an object where you have a key of string and value of, I don't know, a list of integers, or for example, you have a list of objects. It's like a different combination of these, all of these types. Which is kind of similar to what we have in Python. Do we have something similar in Python? Yeah, we have most of these types in Python. But if we're speaking about objects, what is analog of objects in Python? Yeah, it's a dictionary. So it's a structured data where we have a key and value. But in Python, value can be like anything. In JSON, it can be only those types. So that's actually the whole difference between JSON and Python dictionaries. So yeah, let's just Yeah, let's just create some more requests. Let's, okay, so I already started to create this list of objects. Let's continue that. Let's create some more objects. For example, where we have ID of 2 and city of Lviv. So it actually looks like a JSON. So we have a string where we have an object, where we have a key of string. We have a list. Yeah, we have a list of objects, not a string. But here we have a keys of string and value of integer. Here we have a key of string and value of string. And let's just take a look on how FastAPI will handle that. So let's create another GET request with pass homes. And what will it return? Oh, yeah, we should definitely write function. Let's return. What will it return? Obviously, it will return a list in the first place, but it will be a list of dictionaries, right? Where keys are strings and values are actually any, because it can be an integer, it can be a string, it can be a boolean, and so on. Yeah, let's just import this any. And yeah, let's write our function and let's just return our homes. Let's save it. And let's take a look at our documentation, what we'll see here. So in our documentation, we see new route. And let's take a look on how it works here. So here, instead of string, which we can see here, we can see that, yeah, your documentation is generated and it says that as a result of this request, you will receive a list of objects where key is string and value can be anything. Let's actually run this request. Oh, internal server error. That happens. Now we just need to check why we have that error. What?
That's the bit.
Input should be a wallet list function homes. That's interesting. Homes, list of dictionary where string and any.
Thanks.
That's interesting. Do you have any any ideas why we have such error? Oh,
Come into like the tendency of this the direct
Great.
excuse me.
so that columns to account there was inside the command statement the performance
You mean to put?
that the whole fix like that's friendly fun.
I'm not. I guess I'm not understand. Don't understand why. Okay. There.
One who size in it. Nah. Like the best you have a dictionary buttons.
Yes.
I get that sound.
Oh, right. Yeah. Oh, yeah. We should definitely change naming. Let's call it Get Homes. Thank you, Uliana. And when we reload that, you can, yeah, as you can see, we have correct list in response. Yeah, that was not very obvious issue. But yeah, thank you a lot. We can solve that. Yeah, so let's actually add some more requests. And this time, let's add a post request. And actually, for different methods, we can have the same path. That's totally fine. Let's call it, and this time, create home. So actually, what I wanted to show you here is that FastAPI will automatically change your standard types as list, dictionary, string, integers into JSON. So it will understand that it's something similar to JSON, so I should probably convert that to JSON. So yeah, it will do it for you. It will convert that to JSON. So yeah, let's get back to our coding. So actually, we have the same thing for our request. So in order to create home, we need to receive some data, right? We need to receive this home, and this home will as well be a JSON. It will be an object, so it will be a dictionary where keys are strings and values are any. And after creation, let's just return also a dictionary. So, yeah. And code will be like really simple. You can just return home, but also you would like to add this home for your homes. So just like append home. Save it. And again, let's take a look at our documentation. You can see a post request. It has a different color. Wow. Let's take a look here. So here, instead of just response, you also have some schema for your request. So it's also an object. So FastAPI expects an object from you. Let's try it. Let's actually add some home. I don't know, Oslo, why not? And yeah, you can also send post requests from Swagger, not just GET requests. So because I remember some of you have some issues with installing Postman, so you can actually do requests just from Swagger. And it's obviously more easy than do it using curl. So yeah, let's run it. And as you can see, we have a success. But the problem here is sometimes when you create something, you don't just want to return 200. Sometimes it's actually a better practice in this case to return 201. So let's actually change status code of response. You can change that actually from here, from your decorator. And you can write it just like this, but I prefer a little bit different approach. You can also from your FastAPI import status. And this status has a lot of different, it's an enumeration. It has a lot of different statuses that are have this really good naming. So we should choose HTTP 201 created. We can save that. We again reload that. And you can see that now it's expecting it says that it will return 201 for you. So we can again try it out. We can add some ID, 1, and city of, I don't know, Madrid. Oh, okay, 1 is, let's call it 4. And let's actually now make a GET request. Yes, and you can see that our Madrid city is added into our list. But because we reload our server, our previous city is not with us anymore. So yeah, it works. What we want to add now is actually we can add another request, for example, GET request. No, let's actually add some delete request. Let's add some delete request. It's homes and with some ID because we want to delete some specific home from our list. And yeah, so delete home, expect some ID, which is integer, and we don't want to return nothing. And actually for delete, it's also a good practice to send a different status code. For delete, we can always return no content, which actually means that you deleted that successfully. So what you want to do here is actually, okay, so how we can delete by ID from this list? I think we need to write a for loop for index home in enumerate homes if home index home ID equals ID, then we need to pop this value from our list, pop actually this index from our list, and let's return so our loop will not continue working. Let's save that. Let's reload that. And you can see we have this red dangerous delete request. So yeah, let's delete the first element. Let's execute that. Yeah, we have 204 success. And if we run our list now, yeah, so it's just one element here now. But what is the problem here is if we delete nothing, we should tell user that nothing was deleted. We should probably return some error. And how we can return errors in FastAPI? Actually, we don't return them, we raise error, just like we raise exceptions, because actually it is exception. So we need to import HTTP exception here. And in case that we don't find ID, we don't find home with such ID, we just need to raise this HTTP exception with status code. In this case, I think we should use gone, 410 gone, and some details that home is already deleted. Let's save that. Let's reload our screen again. Let's try to delete something that obviously doesn't exist. Yeah, you can see that you have this 410 error gone, but actually your documentation says you that it's undocumented. So before you send requests, you don't actually see that 410 error here. And that's the problem, because your front-end developers won't expect that. So how you can add that to your documentation? Actually, pretty easy. You can also expand your delete request, your delete decorator for that. Not just deleting, you can expand any of these decorators. So you can add responses parameter, and responses is a dictionary that receives status codes as keys. In our case, we want to add our 410 status code, and value is also a dictionary where the first key is description, and value is actually this message that we have here. Let's add it, let's save it, let's reload it. And now you can see that it's already documented. So yeah, that's how you add your exceptions, your error status codes, and that's how you document that. Another good example is when you, for example, very fast example, when you want to get some specific home, async get def get home of specific ID. You also return a dictionary here. Let's write some code as well for home in homes. If home ID, okay, I don't need that here. Home ID equals ID. We want to return our home. So we find our home by ID and return it. And in this case, best practice, if we don't find anything, we should return maybe the most famous error status code in the world. We should return 404. HTTP 404 home not found. And we should really register it here, but just don't waste our time for that. Let's just check how it works. For example, we want to receive ID of 1, we have that, and if we write some random number, yeah, we have 404 with details home not found. That's how you rise errors here. So, but what is the problem with these with all these requests actually is that we can't actually control what data we're sending to our server. Because, for example, if we want to create home, we send a dictionary, but it can be absolutely random dictionary, and there is no checks or no validation at all. So let's again try it. We can send like almost anything here. We have this additional prop. Okay. And we can write also a bunch of some random data. null, for example. Let's send it. Yay, we have success. Successfully added some nonsense into our database. And it's actually not something that you want to do in your real systems. Yeah, we have this nonsense in our list, but in your real systems, usually in most of the cases, you want your database to be strictly structured and follow the same format. So we need somehow to change that. And in FastAPI, in order to implement this validation, we have Pydantic that I mentioned earlier. So, as you can see in your left payload, in your left post request, we have some JSON data that we're sending to our server. It has a title, it has a description, it has some Boolean completed value, and in the right, you have Pydantic model, which looks a little, kind of as your usual Python class. But you just need to extend your Pydantic base model in order to work with it. So it also have a title field. This title field is a string, and it has some limitations. It has minimum lengths, it has maximum lengths, and it has some description. I'll show you later why it has some description. Also, this model has a description, just like this payload. And it can be string, it can be none. By default, it's none. And also, it has a Boolean value where default value is false. And also, it has this payload has exactly the same value. So, for example, if you send this request, we'll receive a 422 unprocessable entity error. Because, yeah, title is a string, that's fine, but it doesn't fit here. So, because minimum length of this string should be a3, and it's just a single character. So you will have an error because of that. And also, you, for example, send completed and null, but this parameter doesn't allow nullable values. So it also will raise a problem for you. So in order to fix that, you need to change your request a little bit. For example, this request will work just fine because now it has 3 characters and now it's a Boolean value, so everything will work just fine. Oh, a little small spoiler. Let's actually add try to add those Pydantic models. So we have our homes here, and yeah, let's create home model. And we want to add some inheritance base. Okay, we need to import that from Pydantic. So from Pydantic, we want to import base model. Okay, command and plus. Oh,
Yeah.
cool. Base model. And let's just repeat what we have here. So we have an ID, which is integer, but actually we can even specify it a little bit more because in Pydantic we have such value as a positive integer. So if we change that type, Pydantic will validate this value, and if it's not a positive integer, if it's, for example, like -1, it will also raise an error. And let's add our city, which is string. But let's add some field for it. And let's also let's say we want this field to have a default value that will be Kyiv, and we want to have it some minimal lengths of 1 and maximum lengths of, for example, like 20. Yeah, and we can save it, and we can at first, for example, use it for our post request here. So here, instead of receiving some random dictionary, we can receive home. We can receive pydantic model. And if we save that, and that won't actually work because still we need to save here our JSON, our object, our dictionaries. So let's, but we can convert pydantic into JSON. We can do it async model dump. Yeah. So if we save that and we reload our documentation once more, we will be able to see that now it's not just some random dictionary. Now it has this strict structure of ID that is integer, positive integer, and a city, and default value is Kyiv. And if we switch here to schema, we will see even more details about this pydantic schema. So ID here is obviously something that is required because it has this red star, I think. It's an integer and it's a positive integer. And a city here is a string, obviously, and there is these limitations that we previously provided. Also, it has this default value. But what else we can add is some description, because it may be not very obvious why we have city in homes. What's even like relation between those two okay. So we can add some description here. City where our home is located. Let's save that. Let's reload that. And in our schema here, we'll see that we have this description here. So it will be also very useful for front-end developers, for example, for users of your API, to know why we have to send this city. Yeah, so let's try it. Let's try it now. Okay. So let's send it. We have internal server error. Interesting. That's very interesting why we have it now. Okay, input should be a valid dictionary where ID. That's interesting. Okay. Why we have this error? Our dictionary, our JSON here is pretty valid. Because we also return this value, and we need to change that there as well, because we also can change that here. So we also return home, not a dictionary. So now when we reload that, we also will be able to see that here we also change that random dictionary to our strict validated format. So yeah, let's try it, let's send it, and this time we see 201 So it's a success. Cool. So now nobody can send some random dictionary to our API and save it into our database, which is cool. Also, it's a common practice where you have different schemas for output and input. So you can send some like limited object to create your to add something into your database, but in response you will like see a little bit different. Okay, I will show you because I think I have some issues with explaining home out. We can create like different schema, but here instead of city, let it be just string. We don't need validation for output here. We might want that, but it's not actually that important in this case. And also we can add some, I don't know, active, which is Boolean. And for example, when we create something, you want to send this schema, but in response, we want to return this schema. So we can use different schemas for request and response. But now we will probably have error because we need to create our home output. Let's just create that home out, and ID will be a ID of home ID, and city will be a city, home city, and active, let's say it will be false, always false. And let's return home out. Let's save it and let's check it in our documentation. So you can see that for request, we see our previous schema, but for response, we see a little bit different schema with this new parameter, which is actually fine, and it's a good practice. So let's try it, let's send it. Yeah, we have success. So that's actually how we can use our Pydantic to validate our requests. So, and we can use that on put request and patch request, on different requests for both input and output. Yeah, so let's, I think, do a break, 10 minutes, and we'll continue after that.
But break, so the time in.
We will continue at 11:32. Go back to our presentation. Guys, can you hear me online? Can you see everything?
Yes.
Yeah? Yeah. I hope. I hope so. Okay, so let's continue. Let's actually talk about middleware. And here we have some examples. It will be much more easier in this case. How do you think? Where is FastAPI and where is your framework? Yeah, it was obvious. I only found yesterday. I only found this example. So yeah, I have only two options. But as well, it's not that different. We have the same, almost the same decorator and the same function with the same arguments and the same call next function. So yeah, it's almost the same. So that's how you create and register and add middleware in your FastAPI application. So here you obviously have a decorator that register your function as middleware in your system. And this HTTP string is saying that
this middleware will work for each and every request that was sent via HTTP protocol, because there might be some different protocols, like, I don't know, WebSocket, for example. But this middleware will only work for HTTP. Also, we have this call next function, which you probably should be familiar with. It just runs next handler, next middleware, or actually original route handler. And yeah, that's actually it about middleware. It works globally for all requests in all of your FastAPI application. So yeah, let's continue. Another problem we might have with our FastAPI in our request is that as app grows, one file, our main.py, will become a mess. And it will be extremely difficult to add new requests, to find this route in your file. So we should probably do some refactoring, do some decomposition to split it to different files. And that's how you probably can solve that. So instead of all your routers, all your routes will be attached that attached to your FastAPI application directly, you can split that in different files, and each and every of these files will have its own router. And then you will connect your routes not to your FastAPI application directly, but at first add them to your router, and then attach your router to your application. So yeah, let's actually do that in code as well. Oh, okay. So here we see that we have all these home routes, and I think we can create a new file and call it home.py. Let's just copy everything that is related to our home, maybe just except of this first test route, to our homes. Okay, obviously we have to do some importing here. Let's just copy that from main. Let's delete that. And yeah, everything should work. But now we don't have application here. We don't have anything to register our routes. So for that, we should import API router. So, and create that actually for our application, for our homes. So yeah, it's created. And now you can register your routes not with your application, but with your router. You just replace your app with your router, because router has exactly the same decorators here. And okay, let's just change that a little bit. One more interesting thing is that router can take a prefix. And prefix is actually a common part of path of every route that that will be connected to your router. So if we add prefix here, we can remove all these paths from here. Yeah, and it will just work. Also, you can add some tags. Home. I'll show you later why we add this tag. And we have some error. It's not closed. Okay, but because we need. Okay, let's save that. But actually now we have to import this router to this file and to attach our router to our application. So let's do that. Let's just remove those unused imports. And from homes, our homes file, import router as homes router. And then you can include this router in your application. Let's save it. Let's take a look at our new documentation. And you can see that you have the same routes here, but now they are grouped under this home tag that we added previously, and each and all of them has this prefix that we also added for our homes router here. Let's actually do some more of the composition. So let's create test.py. Test.py. Let's move this request here as well. Let's create router here as well in this file. Let's import it. Let's change that. Okay. Here we need to change that to test. Change these to test as well, I think. And now you already have this prefix, so you can delete this part. Yeah, and in your main, you can also import that from test, import router as test router, and include that. Just copy paste, save, and reload. And now in your documentation, you see two different sections of home routes and test routes. Yeah, that's cool. That makes navigation much more easier, both in this documentation and in your project folder. So now main.py is much more cleaner, and everything that is domain related, for example, related with homes, is included in this file, which is very convenient. And it's a good practice, so I think you should probably do the same. Yeah, so yeah, let's continue. And now we have maybe the most interesting topic and probably the most complicated. But before that, I want to ask, was everything clear for you before this? Or maybe you have some questions, some issues? Maybe you don't understand something was very kind of difficult. Cool, cool. Thank you, guys. So let's actually start with dependencies. And let's start from the question, what is dependency? Well, dependency is something that cannot exist with something else. So if, as written on slide, if part A cannot run without part B, then part B is dependency of part A. And in terms of programming, of software engineering, dependencies can be other functions, services, libraries, or data that is used in some of your other functions. So I have this real life example where you can see this sleepy guy, and he definitely depends on coffee because he needs this coffee each and every morning to actually, because he cannot run without coffee. He is not productive without coffee. So coffee is a dependency of this sleepy guy. And for example, our route, the same home route may have some other dependencies. For example, it may depend on authorization service, because home data might be like sensitive or private information, and you definitely want to secure this information with some authorization. So just as our sleepy guy depends on coffee, our routes can also depend on some other services and some other functions. So when we know what is dependency, we can talk about dependency injection here. And what is dependency injection? We have this sleepy guy that still depends on coffee, he can create this coffee by himself, but he may have a lot of concerns, because how to create this coffee? I'm not that good at creating coffee. I don't know what beans to use. I don't know how to boil water. I don't want to do it each and every morning because it may take a lot of time. So, yeah, the most obvious solution is to use is to go, for example, to some barista guy and ask him to do that. And it's actually a great solution, because now when he goes to this barista guy, it's no longer his concern how to create coffee. He should not think about any beans, water, and he don't waste his time. It's like, yeah, it's not my concern now. I'm just waiting for my coffee. And this other guy is saying, okay, no worries, it's my job. I know how to do it perfectly. So yeah, this guy still depends on coffee, but he don't do that. He just wait for coffee, and this barista guy will just inject this coffee to this sleepy guy. He will just provide this coffee, and now responsibility of sleepy guy is just to consume, but not to create it. And it's actually the whole meaning of dependency injection, because in our system, we have kind of the same situation. We have our routes, and that may require some authorization service. And our route can create this service by himself inside of it. But yeah, there are still a lot of concerns, because how to create this authorization service? Maybe this authorization service has other dependencies. So at first we have to create dependencies of authorization service, then we have to create authorization service, then we have to use authorization service. It's a long chain, it's difficult, and our routes don't want to know anything about it. And it will obviously make our routes very complicated. And we usually want our routes to be focused on domain that information that we return from this route is related to some complicated sentence, but I hope you understand me. So again, our route just can rely on some other service to create this authorization service. It can rely on FastAPI in this case. FastAPI in this case is our barista. He can create this service instead of us, instead of our route, because FastAPI has really powerful dependency injection system. So yeah, it just provides the result of this server for our route, and our server don't have to waste any time and any space and create this service. So why is it important in the first place? Because yeah, it's a repeating of the code, because we need to create in each and every route these services, and it's not a good idea. It's hard to test and change. Again, it's messy and unclear code signatures. Yeah, and it hurts a lot. And if we use our dependency injection, we have this separation of concerns. We separate concern of creating coffee and consuming coffee. We now only need to think about consuming, not about creating. And we also have this reusability, testability, flexibility. That's obviously because we don't repeat ourselves. We have that in different dependency. Okay, so FastAPI dependencies. That's just how they looks. So dependency in FastAPI is just a function. If we are more precise, it's a callable, something that we can call, because sometimes we can call even classes, right? Classes, okay. So dependency is a function, and you can declare it in parameters of your route using depends that you can import from your FastAPI as well. So, and FastAPI will do everything instead of you. It will do all the calculations here in this function and just provide you a result here. And you will use the result. You don't want to think what computations are, what's going on in this function. You just receive the result. In this case, it's some city library API string, but in more real example, it can be some complicated service, or it can be some useful information like user ID, for example, which is can be important for our requests. Oh, let's also make a fast coding. Let's go to our test route, and here let's just create some function. Create get user ID dependency, and let's create some simple authorization. For example, we want to receive some secret key, which is a string, or none, and none by default. And then for now, let's just return 1, for example. And yeah, in real systems, these codes will execute a huge chain. It will use database. It will use some decoding to decode this secret key to find some information. But now we have for now just like returning this information. Let's inject it inside our request, and we will actually see some interesting things. Because let's do it. User ID equals depends. Okay, we need to import that. Depends on our get user ID. We can save that. Let's actually add that to our let's save that. Let's go back to our documentation. And here in our test, what we can see is that this secret key is now considered as query parameter. So it's not explicitly in declaration of our route, but if we have it here, then our FastAPI will think that it's a query. So this whole code will like move here. It will be like this part, because there is nothing, because there is no way we can provide this information in different ways. So it's considered as a query parameter. Yeah, that's how it works. Let's just run it. Let's try it out. Provide ID, provide city, provide secret key, some data, save it. Yeah, user ID 1, obviously. But let's do some check. Let's create some check. If secret key, if not secret key, then rise HTTP. Okay, HTTP exception. HTTP exception where status code is, okay, status as well. Status is 401, unauthorized. And details, not unauthorized. Unauthorized. Let's save it. And let's make it work again. So now it works, but if we pass nothing, it gives us 401. It's undocumented, but we want to waste our time now to document it, but it works. So it just failed our authorization because we didn't provide secret key. Okay, so it still returned for us ID if we do everything correct. We can also make small changes here because, as you can see now, our user ID parameter is any. So our IDE for VS Code won't understand that it's an integer. So yeah, we can fix that like in this way. It will be an integer, but depends by itself don't return any type, and that's can be problematic. And the best way to add dependencies is to use annotated. For example, you can have this user ID, and you can copy that here and use it in this way. But it's still the same. It will return like any value. But you sometimes want it to return a specific value. And in order to do that, you can use annotated from types import okay, annotated. Let's take a look. From typing, not from type. Okay, and here you can write that it's an integer and write a dependency. And now you can use it not like variable, but like a type of your variable, of your parameter, and move it because it has no default value, and move it here. So it looks way cleaner in a declaration of your route. And yeah, it still works. You can save that, can reload that, can try it out. PCT, secret key. Yeah, it still works. But now it looks cleaner, and you can use your user ID as integer. Obviously, it has everything that integer has. We can do that even more complicated. We can use this dependency not just for any route, not for some specific route, but for the whole router. For this, we need to add dependencies and pass this dependency here. Yeah, we need to. Yeah, now it works. So obvious advantage is that this dependency will be used on each and every request. So, for example, this check will be used on each and every request. But disadvantage of this approach is that you can't use return value. So this user ID won't be reachable from your route because it's now in your router. So let's remove that for now. But yeah, you can do that in this way. You can protect the whole router with some checks. Yeah, let's make it a little bit even more difficult. Let's create some secret database, which will be just a dictionary where a key is ID, for example, like secret 1, and value is ID, and for example, the same for secret 2, and 2. And you probably want to use the secret database inside of this function, but it also will be a dependency for this function to use this database. So it's also a dependency. So you need to wrap it in dependency. So let's create get secret database function that will actually return this database for you. And yeah, let's just use some more, create new dependency here. We can use it, we can create it also in different ways, but I prefer this way. Secret database equals annotated dictionary of string and integer that depends on get secret database. And here you can use that database. Guys, is this difficult? Is this confusing? It's tough. Okay, database. You can use this dependency. You can use now this secret database in your dependencies. Now we have a chain of dependencies. You have a route that depends on get user on user ID, and you have user ID that depends actually on your secret database. So it's a chain of dependency, and FastAPI will handle that for you. It will firstly create database and provide it for user ID, and then create user ID and provide it for your route. So you have this sequence. Back. Yeah.
So in this example, where is barista? What is barista in this abstraction?
FastAPI is barista. He do everything for us. So you think it's not a good metaphor?
Yeah, but barista is a method. Yet, for example, get secret database is a. We can say that this is barista. Because
no, it's a coffee. It's a coffee.
Coffee is a database. And
yeah, but it's not a callable in context. In context of FastAPI, it's not a callable, but dependency should be callable. It's something that maybe, but actually it's FastAPI that do everything for you on each and every request. It creates everything.
Database is a coffee in a mug.
Get database is a coffee bean. Coffee is get user ID.
Okay. So get user ID is a coffee in a mug.
Yeah.
So
maybe, probably.
Okay. So the line where you would say depends get user ID is like a request for a coffee barista who is a FastAPI who doing something under the hood.
Yeah, I think, yeah, it's like you saying that I expect this dependency in the future. I expect coffee in the future. So it's like, yeah, it's like your order of coffee.
I think we should create our own dependency injection system in our framework.
Yeah, that will be a very interesting assignment. We should
look at it. It's a dependency injection, something that some developers in production understand after a few years working. So dependency injection stuff, but you will understand it at some point, maybe in a year, maybe tomorrow.
Yeah, but let's just quickly continue. Let's finish this example. So we can really use this database now. So yeah, database. We shouldn't just return one. We can get some of key or else none, and user ID equals. So yeah, in this case, we will retrieve this user ID in case if it's existing for this secret key. And now if user ID, we just return user ID. And if not, we again raise the same exception. So now we have this more complete example of how this thing can be useful for us. We can save that. We can reload again, and we can try it. So now when we write something, and write nothing, it obviously now if we write secret 2, it has user ID 2. Wow. So it goes to our user ID service, then it goes to our database and use all these dependencies in a chain. Cool. So yeah, that's actually all about dependencies. So we can continue with the final topic, which is also very, very useful and very important. So let's play again this game. How do you think? This is like the last level. It's very, very difficult. Final boss. Just guess in this point.
Yeah.
Maybe. Maybe D, yeah. I forgot to add whose code it was, but yeah. Just trust me, it was your templators. So yeah, it's obviously not that obviously, but it's Jinja 2 templator, and it's this is how the code looks for this templator. Looks exactly the same as your templator. So let's continue. It has now we have this more complex example. So here you can see that it has exactly the same variable usage. Also, it has exactly the same for loop. Also, these conditions, if else. But interesting thing here is that it has these local variables, so you can declare your local variables, initialize them, and then use in the same template, which is kind of cool. You didn't have that in your template, but it's okay. But in result, you will receive this HTML with header and this list that is conditional. But also it has Jinja template has a lot of different very useful things such as comments, very useful, macros. I want you to think about macros as about functions that take some arguments and receive and return HTML code in response. You have that in your materials, so you can take a look at that later, not earlier, later. And you also can use include just to take the whole code, the whole HTML code from other file and just paste it inside of your HTML template. So that is also very useful. Maybe the best use case is a footers on site, because they are always static and the same on each and every page of your website. So you just take it, you just write it in different file and then just include it in each and every file. So it's kind of easy, obvious, and makes your code, you don't repeat yourself. And the most interesting thing is template inheritance that also Jinja 2 provides. So here you can see that you have this base template of each and every of your HTML file. It has this common doc type, HTML header, body header, header, and so on. And you have these blocks inside of it. And it's your base HTML file. And then in your child HTML, you can extend your base HTML file. And just like in class inheritance, you can override those blocks. So now, for example, in this block of title will be displayed not my site, but task page, because you override this block. And the same thing with content. Here it's empty, but in child, you can override that and to paste that in this instead of this block. And for example, this footer is not overwritten. It's not overwritten, right? So it will remain the same. Cool, guys. Cool. You will have everything in your materials. So yeah, I suggest you to take a look because it will be in your practical assignment. It makes your templates, the whole layout much easier and much decomposed. So yeah, that's a cool thing. And actually, how you can use Jinja? First things first, you need to install it. Pip install Jinja 2, and then you should first of all create this templates object and pass your template directory. It sometimes it's just a different directory in your root, in the root of your project. So yeah, you just create that, and then in your route, you should obviously mention that the response class should be HTML response. So again, your documentation, in your documentation, you will see that it's expected to receive HTML as a response. And then using the same templates, you just return template response, where you pass your request from your route, you pass the name of your template that you want to return in this response, and provide for these templates some context. For example, if ID is expected, you pass ID. If something else is expected, maybe some like list or some object as well. You can also pass it as a context. And one more interesting thing is URL for that can, also you can add static files. So for example, if you have some CSS or like some static images, you also want to store it in some different directory in your API, in your FastAPI project. And then in this way, you can connect these static routes to your FastAPI, and then you will be able to use it on your templates. So yeah, the last thing probably, the last thing probably is this URL for. It will convert the name. You can provide for this function the name of your methods. For example, here you have read item, and you just provide read item and expected parameters of this read item. It will automatically convert it for you to pass to this pass. So sometimes it can be useful. And the same thing exactly with static files. So you provide static, which is name here, and you provide a path to your specific file. In this case, it's CSS, and it will return for you this string unit. Yeah, so that's all for our lecture.